Hi everyone. Here in this topic, I'm going to talk about advanced graphing. So when you learn all those topics from 10, 11, 12, 13, which are kind of applications for you in other courses in chemistry and so in lab and those things. So you need to know advanced graphing as well. And when I was marking the test, the test or quiz, I noticed that you really need to do more practice on graphing since it's online. So we couldn't see each other, so we couldn't really emphasize on these just graphing of experimental datas, and you really need to do more practice because you need these for your lab courses, for your professional courses, for your future, and for your job in future. You really need to know how to do graphing and how to try your best to make your graph to look good. You and other people understand the graph, and reading the graph is a knowledge that you really need to practice on it. And by marking the quiz, I noticed you really need practice. Some of you need more practice on the topic. I want to emphasize, please make sure to save these videos. I don't say they are perfect, but these are just reference for you. For some parts, you know much more than me because you know those applications more than me, and but at least you know what you need to do and what practice you need to do, and so what do you need here. Advanced graphing. So here, so we talk about, for example, two properties that, for example, we have, and one of them we can graph it on x-axis, one of them on y-axis, and then we talk about interpolation. Means, for example, I have two values on y, and I want to know if I have these values on y, and if I have this graph, and if I accept these data, so what is x value related to those y values that I have? So those x values are unknown. I don't know them. How can I find them? Okay, so look at this example here. This example here. So look at this. So I wrote everything in red, green, and blue, different colors, because I want you to follow and understand what's going on here. Okay, so make sure to read through OneNote, make sure to save them, to save the videos, and make sure to just work on Excel and keep it for your future reference. Okay, so look at the first column. The first column is concentration. These concentration, okay, so they are made, so this concentration, you make them, okay, you make them, you have them in the lab, for example. Then by lab equipment, you measure percent transmittance, okay. So what is the problem in terms of chemistry, in terms of reality, in terms of, for example, if we work on physics, in terms of physics, or in terms of just outside of math, you know much more than me. Okay, so here we talk about mostly just graphing of these things. Okay, so the concentration, so is there in the lab, for example, or they are, so you make them, you make some substances, you make this concentration, you have them, for example, and then you measure using equipment, you measure percent transmittance. The third column, which is absorbance, is calculated by the formula here, which is here, this formula. Okay, by this formula. If I can work on, yeah, this. Okay, so 2 minus log percent transmittance. Okay, so I use the second column in order to make the third column. What is 2 minus log 100? Log 100 is 2 because 100 is 10 power 2. And you learn how log works in Math 273. Okay, so, but for now, you can just use your calculator. 2 minus 2 is 0. Okay, so, and the next one, and the next one. So, you have the first column, you measure the second column, and you calculate the third column. Okay, so that's the red part you read. Then, what is the problem? The problem is, if I have two values here, if I have two values percent transmittance, of course, I can use the formula 2 minus log percent transmittance to find the observance. Okay, so the blue one. But I want to know how can I find these two unknown values for concentration. Okay, so if I accept column number 1 gives column number 2 and column number 2 gives column number 3, if I have two values on column number 2, of course I can find the value on column number 3, but what is the related value on column number 1? These are unknown or highlighted in green. How do you find it? So I explained in the blue part. We use the same method of graphing that we did before. So we look at the values, we find the maximum values, we look at the minimum values. Maybe we have to do maximum minus minimum. Maybe minimum is very small and we don't need to do that. Then we divide maximum between how many parts I have on the graphing paper. So in the quiz I talked about 15 by 15. Here also is 15, 15. But if I have 20, 20, if I have 10, 20, I have to divide by those parts. So I divide and I make the graph using topic 4 techniques. Okay, so look at here. I made the graph. So look at here. I have on y-axis observance, the maximum value is 0.5 5157. So I rounded to 0.6. Then I divided by 15, 0.04. So I can go 2.5 by 2.5. Okay, so every 2.5 I can jump 0.1. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Perfect. I divided y values on y-axis. I divided observance on y-axis. Okay, so I look at my maximum, I divided by 15. This is what we did in topic 4. Make sure to do practice on it. In the quiz, you need to do more practice. Okay, so then I do concentration. Concentration, the maximum values are 9. Okay, so I divide 9 by 15. So it's 0.6 each part. Okay, so you can just, divide that and you can say, okay, so 0.6. So I can say, okay, so for each part, I can go by, for example, consider each part for each square. So for each square, I can jump for example, let me see, divide each square to 3 parts and consider each part to 0.2. Okay, so how? Because I have 9 and I divided by 15, so it's 0.6. Okay, then I can divide each square to 3 parts and consider each part 0.2, and then I can jump, so 0.6 and then 1.2 and then, okay, or maybe you want to round up to 1, for example, and then you want to say, okay, so I go 1, 2, 3, and then I reach to 9. Okay, so and then you have some left, so some part left. Doesn't matter. Okay, so you try your best. Here I want to try my best, so I would say, okay, I divide 9, which is maximum value for concentration. Look at here, 9 is maximum value for concentration. I divide it between 15, this is 0.6, and I can say, okay, so I make each square divided by 3 and each one I go 0.2. Okay, so here means this is 0.6 and the next one is 1.2. Okay, so I can do that, and then I can say, okay, everything is divided between 9 parts. Then after I plotted all the points, so after I did that, we can use a ruler to make a line of best fit. Okay, so this is what you learn in the lab. Okay, I am going to show you to do this with Excel, so that's more accurate and much easier. Okay, so you make the line of best fit, and then you look at the value you have here. See, these two values are values you have, and then you made these two blue one. So these two values are on y-axis. Okay, so I can find them on y-axis. These are approximate. I find them here, green. You can see they are highlighted in green. Then I make a perpendicular line and reach to the, see, I make a perpendicular line and reach to the blue line that you can see, and reach to the green line, to the red line. Then I make another perpendicular line and I reach to x-axis. Then I can say what is my unknown, because I am looking for two unknowns on x-axis, two unknowns on concentration. Okay, so I have two of y values which I can make these two parallel blue line reach to the red line, and then from there I come down. I make a perpendicular line on y on x-axis, and then I can say I think it is 4 and 6. That's almost, so which I didn't know, so this 4 and 6. So I look at here and I say, okay, so yes, one of them is 4. So see, I have concentration 0, 1, 3, 5, 7, 9. Now I have 4 and 6. Okay, so I found them. Okay, so these are what was unknown. So okay, make sure to read the file. The file is in OneNote. Okay, and you have access to OneNote. Okay, so beautiful. So I have all these values on x-axis, concentration. I calculate percent transmittance, then measure by equipment in the lab. Then I calculate by a formula observance or y, and then I graph them. So I graph concentration on the x-axis, observance on y-axis, and then I use two y values in order to find two x values which I didn't know. Okay, so now my problem was graphing the line, and my problem was graphing my datas, and my problem was graphing the line of best fit. So how about if I can make this easier for myself? I want to do it by Excel. Okay, so I'm going to explain Excel later. So you know much more than me in these things, I am sure. But I try my best to explain it so you can keep it as a reference. Okay, so the next example here, the same. The first column has been made, the first column. The second column is measured by equipment, as I said. The third column is calculated. Yes, it's calculated. So then I use the same method just to divide between 15 parts, and I can, the same method I did in topic 4. And some of you did a good job in the quiz. Some of you really need to practice, okay, in order to graph it. So I did graph it, and then I can find these two values on y-axis. For example, see, I am looking for, where is it? So see, we use formula and find these two. Okay, now we have these two values. Okay, I have these two values on percent transmittance. Okay, on the second column. Okay, so I have these two values. I can calculate observance of these for these two values. Yes, I can. Then we use the formula. We use the formula to find these. Then I can find these two values. One of them is 0.05750 and one of them is 0.5719. So one of them is here, one of them is here. Okay, so then I make a perpendicular line here, I do here, and then I come down and I say, okay, one of them is almost this, and one of them is almost 1, one of them is almost 13. Okay, so these are all approximate and all of them are possible, but it takes time. I have to take time to make the graph. I have to try my best. Maybe I make a mistake. Then I have to make line of best fit with ruler and everything. It's hard. Okay, and then I have to calculate. Everything is not really accurate, and it takes time, and maybe I make mistake. Now I say I use Excel. I use Excel and I do everything with Excel. I give data to Excel. I ask Excel to make the line of best fit for me. And even I ask Excel to give me a formula. Excel gives me a formula between Y and X. Okay? Line of best fit. Remember, this is not exact for all the points. It's approximate. But it's line of best fit. Okay? So here is concentration and here is observance. Okay, so it says this is the formula between observance and concentration. Okay, and then if I have two values on Y, then I can find X. And I found it using the formula, and I see it is almost the same as what I did here. Almost the same as these two values are almost the same here. Okay, see, one of them here is 13 multiple 10 power minus 6, which is 1.3 multiple 10 power minus 5. Look at this. This is 1.3 almost, and the other one as well. The other one is, see what I found there is 1 multiple 10 power minus 6, and here I have 1.3 or multiple 10 power minus 6 using the formula. And remember, all of them are exact. All of them are approximate, not exact, but this is much easier because I'm doing it by Excel. Okay, so I give data to Excel. Right now I am going to do so, and I'll make another video for that, and then I try my best just to explain step by step, and also you have the file, and you can practice on your own. The file is here. So the file is also posted in OneNote. You can see them. You can save them for later and do practice on them. Okay, so in this case, when you have Excel file, you can give the data to Excel. You can ask Excel to make the line of best fit to give you the equation. And then when you have the equation, if you have two values on Y, then you can find X. And you don't need to go through all of these. And maybe it's so you have less chance to make mistake, and it's more accurate. Okay, so right now I am going to stop here, and I can talk about Excel file in another video. Thank you for your time. Bye.